Texan Global School. Trigonometric equations. In this class, we will analyze processes to solve trigonometric equations. To solve a trigonometric equation, we will use algebraic processes for solving linear equations, isolating variables, processes for solving quadratic equations, among others. Likewise, various tools such as exact values, functions, and trigonometric identities will be used. Let's see a first example. We will solve the trigonometric equation 2 sine of theta minus 1 equals 0. In the given domain, representing values greater than or equal to 0 and less than 360 degrees or 2 pi. By analyzing the equation, we can solve for the sine of theta using properties of the equations. Thus we obtain that the sine of theta equals 1/2. If we use exact values, we can see that 30 degrees or pi sixth correspond to the sine of theta equal to 1/2. If we analyze the sine function graph in the given cycle, we can see that pi sixths correspond to 1/2. It should be noted that, in case of not using the table of exact values or the function, this value could be obtained by isolating theta as arcsine of 1/2, thus obtaining 30 degrees. However, to the value of 1/2, there is also a second element of 5 pi sixth. In this way, result in two solutions for this trigonometric equation. When theta equals 30 degrees or pi sixth, and when theta equals 150 degrees or 5 pi sixth. In this second example, we will solve the trigonometric equation, square sine of theta minus 2 sine of theta equals 0. In the given domain, representing values greater than or equal to 0 and less than 360 degrees or 2 pi. By analyzing, factor to solve the equation, resulting in the sine of theta as a common factor, times the sine of theta minus 2. Then, set each factor equal to 0 and isolate. In the first case, using the table of exact values, we see that the sine of theta has two solutions, when theta is 0 and when theta is pi. Now there is no value for the sine of theta equal to 2, since the amplitude of the function is 1. If we try to solve it using a calculator, we will see that it will send an error when applying arcsine of 2. It can be verified in the sine function graph, since the angle corresponds to those two values when the amplitude is 0. It should be noted that 2 pi is not a solution, since the domain interval is open. In this way, we obtain two solutions for this trigonometric equation. When theta is equal to 0 degrees or 0 radians, and when theta is equal to 180 degrees or pi radians. In this last example, solve the trigonometric equation 2 cosine of theta minus square root of 3 equals 0. In the given domain, representing values greater than or equal to 0 and less than 360 degrees or 2 pi. When analyzing, isolate, obtaining cosine of theta equal with the square root of 3 over 2. With the exact values, an angle of 30 degrees or pi sixths corresponds to it. With the calculator, solving for theta, with the arc cosine of the square root of 3 over 2, also results 30 degrees. By plotting the graph of the cosine, we can analyze the solution. We can see that there is another value, which is 330 degrees or 11 pi sixths. In this way, we obtain two solutions for this trigonometric equation, when theta equals 30 degrees or pi sixths, and when theta equals 330 degrees or 11 pi sixths. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com